Hello. Now we see one universal law, that is Newton's law of gravitation. There is a force of attraction between any two bodies, that may be macroscopic or microscopic. Let us one example of macroscopic bodies. Just we have seen every planet revolves around the sun, and the necessary centripetal force for the motion of the planet around the sun is provided by the gravitational force of attraction. We can take one more example. Moon revolves around the sun, sorry, Earth. Necessary gravitational force for the motion of the moon around the Earth is also provided by the gravitational force of attraction between the moon and the Earth. We can take one big body and one small body. Any object, say this is chocolate, which is thrown in upward direction, returns to the Earth's surface because the Earth exerts the force of attraction on that object, which is a gravitational force. The same is true for microscopic bodies. Microscopic bodies, very small bodies, there also a force of attraction between these two bodies. And this force of attraction is called as the gravitational force of attraction, and this is applicable or true all over the all universe, and therefore it is called as the universal law of gravitation. Suppose we have two bodies or two particles, first having mass m1, another having mass m2, and if r is the separation between them, the distance between the two bodies is always measured from center to center. Okay. According to Newton, the every particle of matter attracts every other particle. The same thing happens in case of second. Every particle of matter attracts with every other particle with a force, and that force is directly proportional to product of their masses. If m1 and m2 are the masses of these two particles, then F is directly proportional to m1 m2. Also, this force is inversely proportional to square of the distance between them, and therefore F is directly proportional to m1 m2 upon r square by combining these two. Okay. So Newton's law of gravitation, again we can see this statement: every particle of matter attracts every other particle with a force which is directly proportional to product of their masses and inversely proportional to square of the distance between them. Now, if we replace the proportionality sign by taking equality sign, then we have to take constant. So that constant is g m1 m2 upon r square. So this is the formula for the gravitational force of attraction. Okay, this constant of proportionality is also called as the universal gravitational constant, or we can say that gravitation, constant of gravitation or universal gravitational constant, because the value of this G is 6.67 into 10 raised to minus 11 Newton meter square per kilogram square, and this is constant everywhere in the universe, and that's why it is called as the universal gravitational constant. And the dimensions of gravitational constant is L3 m minus 1 and t raised to minus 1. So these are the dimensions of constant of gravitation. So this is about the Newton's law of gravitation. The statement is very important. Every particle of matter attracts every other particle with a force which is directly proportional to product of their masses and inversely proportional to square of the distance between them. Okay.